Hello, my name is Erin, and today we're going to be talking about evaluating expressions. And so before we start, I think it's super important to get accustomed to a couple of terms. And so the first term we are going to talk about is a variable. And a variable is simply a letter or symbol that represents some unknown value. So for example, the letter X or the letter Y can be a variable. A constant is simply a fixed value. So for example, the integer 5 can be a constant, the integer 10 can also be a constant, and an algebraic expression is simply a combination of the two. So for example, x plus 5 is an algebraic expression. Here's an example problem involving an algebraic expression, and it reads, Molly has 3 more bikes than Tom. Write an algebraic expression that represents the number of bikes Molly has in relation to Tom. And so we need to know the number of bikes that Molly has, but in order to do that, we need to know first the number of bikes that Tom has. And so we see, however, that the problem doesn't state explicitly the number of bikes that Tom has, and so we're actually going to represent it with a variable, right? And so the variable that we're going to choose, just because Tom's name starts with a T, is going to be T. And so we know that Molly has 3 more bikes than Tom, and so if Tom has T number of bikes, Molly has T plus 3 bikes. And so that would be the algebraic expression. Next, we're going to talk about something called the order of operations, and this is simply when you are given an expression that involves multiple operators. This acronym here on the side, Pemdas, actually gives you an order in which to solve these many operators. And so you can take a minute to pause and just read through what each letter stands for. But what this basically means is that when you're given an expression, you're going to solve the parentheses first, and then you're going to solve the exponents, and then the multiplication, and so on and so forth. I do want to note a quick exception to this order, and that is, let's say you're solving an expression. You solve through all the parentheses, you solve through all the exponents, and all you have left is just some multiplication and division to do. And so in that case, regardless of whether the division comes first or the multiplication comes first, you're going to go simply from left to right. The same rule applies to the addition and subtraction. And so let's say you're solving an expression, you go through all the parentheses, exponents, multiplication, division, and you're left with just the addition and subtraction. Again, regardless of whether the subtraction precedes the addition, if just these two are left, you're just going to solve from left to right, and you're going to see what that looks like in just a minute. And so here are 2 example problems that will kind of help us go through these order of operations. And so we're going to start with this first one. I'm just going to write Pemdas for us on the side, just so we can keep it as reference. And so we're going to start with parentheses. We see that we have 4 plus 10 right over here within the parentheses. And so when we solve that, we're going to get 10. We're just going to bring everything that we haven't used down, right? And so we're just going to keep the 5 minus 7 times 4 plus 2. And in this case, we're just going to keep the parentheses just because that parentheses does represent the 2 times 10 here. And so we're just going to keep it. And so we're done with the P. We look and we see that there are no exponents, and so we're going to move on. We do see that there is a decent amount of multiplication. We have multiplication right over here and multiplication right over here. And so we're going to solve this one first. 7 times 4 is 28, and 2 times 10 is 20. And again, we're just going to bring down everything that we haven't used. And so 5 minus is going to come down, the plus sign is going to come down, and now we are done with the multiplication. We see that there's no division in this problem, and so we're just going to cross that out as well. And now we see that we're left with just addition and subtraction, right? And so we know that when that is the case, you can simply just go from left to right, regardless of the order, right? And so if we go from left to right, we can simply solve this question. So 5 minus 28 is negative 23, plus 20 is going to be negative 3. And that's going to be the final answer. Now I'm going to ask that you take a minute to pause the video and go ahead and try the second problem right over here. Okay, so hopefully you had the chance to try that. We're going to work through this one together. And again, I'm just going to write Pemdas on the side just for reference. And so we're going to start with parentheses. But the first thing we notice here is that we have 2 sets of parentheses, and within both of these parentheses, there's a lot going on, right? And so an important thing to note about this case is that you want to preserve the order of Pemdas even within the parentheses, right? Meaning that if we start with this parentheses right over here, right? we notice that there is an exponential value, right? And we know that exponents comes right after parentheses. And so we're going to actually go ahead and solve that first, as opposed to just going left to right inside of the parentheses. And so again, the biggest hint here is to preserve that order. And so 5 times 5, or 5 to the power of 2, is 25. We're just going to bring everything else down, right? And so if we solve that, 3 times 25 is 75, divided by 15 is going to be 5. And so we're done with that parentheses. We're going to move on to the second parentheses. Again, instead of just going from left to right, you want to preserve that order. So that exponent there tells us we should solve it first. And so 5 minus 2 to the power of 2 is 4, right? And that's going to be 1, right? And so we are done with those parentheses. We're going to bring down everything that we haven't used. And so in that case, that's the subtraction side, right? The subtraction side right over here. And so if we bring that down, 5 minus 1 is going to be 4. And hopefully that's the answer that you got. Okay, so we're going to move on to this last portion here, which is evaluating expressions. And I just wrote down a couple of important hints for us. And so when you are evaluating an expression, there's often a lot of substitution and replacing involved. You always want to make sure that you follow the order of operations, or you want to make sure that you follow Pemdas. And so I've kept it on the side for us. If you're substituting negative numbers, make sure you use the parentheses, and you're going to see what I mean by that in just a minute. And always simplify as much as you can. Simplification is the key here. And so we're going to go ahead and try a practice problem. And the problem says, evaluate the expression 5x plus 6y if x equals 3 and y equals negative 4. And so by the definition of a variable is some unknown value, right? And so in this case, 5 is multiplied by some unknown value, x, and 6 is also multiplied by some unknown value. However, this problem actually does give us the values of the x, right, which in this case is 3, and the value of y, which in this case is negative 4. And so what you're going to do is you're simply going to substitute these values into the x and the y here. And so to make that a little bit simpler for us to visualize, I've actually color-coded it here for us. And so we see that this 3 directly replaces that x, right? And this negative 4 directly replaces that y. And so if we were to just write this out now mathematically, that would be 5 times 3, right? Or a better way to represent that would be with parentheses, plus 6 times y, which is negative 4, right? And so now here, again, make sure that you're following Pemdas. And so we see that there are actually no parentheses, no exponents. There is multiplication. So we're going to go ahead and multiply this out and then multiply that out, which is 15 plus, because we're going to preserve, we're actually just going to bring that addition sign down, minus 24, right? And so if you solve that, you're actually going to get negative 9 as your answer. And so hopefully that makes sense. I'm going to ask that you go ahead and try this problem down here. Take the time to pause the video, and then we'll try it together in a second. Okay, so hopefully you had the chance to try that out. Again, the same logic applies. We're going to substitute any of these x values with negative 6 and this y value here with the 2. And so if you were to substitute that in, 7 times x is negative 6, minus 2 times x, which is negative 6, and the y is a 2, right? And so again, I'm just going to write Pemdas here for us. There are parentheses, but those parentheses are referring to multiplication, and so we're going to skip that. There's no exponents involved. There is some multiplication. You see multiplication here and multiplication right over here. And so that's going to be negative 42. And this over here is going to be 12. This is going to be 24, right? And so if we were to solve that, that would be negative 18. And so hopefully you were able to get negative 18, and hopefully this video was helpful.